Alright guys, today we have another lecture, and that is about basket floats in a bathtub of water, uh, and the ball has a mass of 0.5 kilogram and a diameter of 22 centimeter. Actually, the this the example is about the buoyant force, and we have in this case basketball, and that floats in a bathtub of water. Means there is a water in the bathtub, and the basketball floats in it. The ball has a mass. The ball that floats in the water has a mass of 0.5 kilogram and a diameter of 22 centimeter. Now we have here data, and that data is 22 centigrade. My pen is not actually working very finely. Let me check what happened to my device. Okay. Now we have three small theories. What is the bind force? What is the volume of water displaced by the ball? And what is the average density of the basketball? Let's discuss these three one by one. As we have a basketball in a bathtub, and that floats on the water. In the water, we have water in a bathtub, the water, and basketball is inside the water. Like this is a basketball. Now, what is the bind force? To find out what is the bind force, simply draw a free body diagram. The force of gravity is balanced by the bind force. That we have a basketball, we have downward force, and definitely we have upward force. If we apply Newton's second law, that says sum of force equals mass times acceleration. And we are very well aware that in this case, in this particular case, we have 0.5 kilogram of mass, uh, and if we cancel the forces, we have bind force minus the force of gravity that attracts the ball downwards. And when we apply this equation, that equals a value of 0. And when we insert the values into the formula, 0.5 kilogram mass times 9.8 as gravity, that equals 4.9 newtons. That we have some force that is 4.9 newtons. So in this case we have bind force, and that bind force is 4.9 newtons. The second question says, by Archimedes' principle, the bind force is equal to the weight of displaced. Means the bind force that is downward in this case, that equals to the water or liquid that displaced this is the archemedies principle. That this area, we have a ball, and then the ball is submerged in the water, and some water is displaced because of volume of the ball. So Archimedes principle says the buoyant force is equal to the weight of fluid displaced. Let's discuss this. The formula says in this case the buoyant force equals density times volume of the displaced water times gravity, and that says volume displaced equals, like we are very well aware of this formula. Volume is equal to, in this case, like we have mass is equal to density time volume displaced, and when we are very well aware that volume is equal to mass divided by density. By applying this formula into the equation here, we say the buoyant force, like we have a buoyant force formula, like second Newton's second law. It says mass times gravity, and when we replace, substitute the value of the mass in this case, we say the volume of the displaced water times density times gravitational force. Gravity, Earth gravity. So when we apply this form, we can say volume of displaced water equal to buoyant force times density times gravity. And by inserting the values into the formula, we are very well aware the density and the times gravitational force, constant values, and we find out 5 times 10 to minus 4 meter cube the volume. In the third question, we have what is the average density of the basketball. We know the volume of the sphere is 4 by 3 pi r cube, and we know the diameter of the basketball in this case is 22 centimeter. And when we convert centimeter into meter and find out the radius equals to 0.11 meter, the volume of basketball that we found already, and now volume by using this formula we find out the volume of the 4 by 3 times pi, value of pi times radius, and that is 0.11 to cube, and that is our volume 5.5 5.5 times 10 to minus 3. Alright, the density is the mass divided by volume. We are very well aware of this formula, and by using the values, mass 0.5 times the volume, we found out that equals density 90 kilogram per meter cube. Another way to find the density is to use the volume, the displaced volume for a floating object. The weight of the object equals the buoyant force. So by using the same Newton's second law, we have mg equal to buoyant force. That equals the density of the fluid times volume displaced water times gravity, Earth gravity. And by inserting these all values, we found out that density of the object equal to the density of fluid times the volume of the displaced water. And factor of g cancelled by arranging this is for by rearranging the equation, we found out the density of projectile divided by density of fluid equal to volume of the displaced water divided by volume. And that was what about buoyant force. I guess you like this all today, and I hope so. You enjoy all. We'll meet in the next lecture, and